The first lecture in this section is an introduction to Simulink and how to get started with it. But before that, you need to know what is Simulink. Simulink is a graphical programming environment for modeling, simulation, and analyzing dynamical systems. It was developed by MathWorks company and it comes as a part of the MATLAB software. Simulink is blocks environment, which means it uses blocks connected to each other to perform certain functions. In order to open Simulink from MATLAB, select Simulink Library. Or in the command window you can type Simulink, then enter. The Simulink has two windows. The first window is the Simulink Library browser, which contains several libraries. Each library contains blocks. The second window is the workspace window, in which the Simulink model is constructed. The Simulink Libraries window contains different libraries in different areas in science and engineering. For example, for electrical engineering applications, there are libraries like Communication System Toolbox. There are other libraries like Aerospace, Neural Network, and so on. There is also the Simulink library, which contains sub-libraries like commonly used libraries, sinks, sources, and so on. Each library contains the different blocks. Again, each block has a certain function. The Simulink model is built by inserting the different blocks in the model window. The blocks are connected to each other and forms what we call a process model. Now, let's create our first model in the Simulink. We will build a simple model of sine wave, and after building this model, you will learn about some blocks like sine wave, scoop, gain, mask. You will learn how to insert models in the Simulink model, how to connect the different models, and how to simulate and see the results. The purpose of this model is to display the graph of a sine wave and compare it with another one with a gain of 3. Now, let's insert the sine wave block. The sine wave block can be found in the sources library. The sources library contains the different signals which can be inputs for different systems. Now, let's drag and drop the sine wave block. If I double click the sine wave block, a window which contains the block parameters will appear. In this line, as you can see, the sine wave equation with the different parameters is written. O of t equals to amplitude times sine of frequency times time plus phase plus pass. And frequency here is in rad per second. If you scroll down, you can assign some values to the parameters. In this example, I will leave the default values. Now, in order to display the simulated signal from the sine wave, we need a sink. There are some different types of sinks, and we will look at them later on. But for now, I will drag and drop the scoop sink. The scoop sink is used to display the signal as a graph. Now, I will drag the arrow of the sine wave and connect it to the scoop. The model is ready to be simulated. To run the model, select Run. It takes some time for processing and the result will be ready. In order to display the graph, double-click the scoop block.